This little circuit is what I've designed to apply the brakes when I adjust the voltage. So I have that on this control over here. It's currently set for maximum, so as soon as it gets up near 40 volts it likes to put the brakes on. But you can turn it down, so depending on your resistors you can adjust it. So this is on full brake at present, until I get the new braking resistors. So the one thing about braking resistors is you mustn't put them close together. They've got to be as far away as you can put them. So if you put this one by the side of another one, it's just going to overheat and it'll burn it out. So you've got to keep them separate. And it's the big pieces of steel, a steel frame shed. So the steel is the heatsink, and the set is one up on the top, and then one on the other side. So they couldn't be further away from each other if you tried. This other one, this big one, that one will be fitted over on the left, round about here somewhere in the middle of the garage. So that'll fit right in the centre there, sort of on the steel plate that's down here, waiting to be fitted. So that'll be the heatsink for that big one. So you must not touch these once the brakes are on. Do not touch them, it'll take the skin off your fingers. They get really, really hot. So this one I think it was a 2000 watt. Let's see. Somewhere on there tell us what it is. There you go. Okay. 20 ohm, 1000 watt 20 ohm. So that's just that's for a 48 volt turbine, not for a 24. And the other ones are the same. These are not for the 48, not for the 24, they're for the 48. So that's why I've got the brake on full, so that it doesn't get too out of control until my new resistors arrive, which have taken up to 8 weeks for now, and I've still not got them. Now, because originally this turbine, this inverter burned out, so I bought a new one for the 48 volt winding that I got delivered. That went into this one. Just switch this off. So this is a 48 volt 2000 watt. It can only provide 1800 watts. So if you get a turbine that generates more power than that, it will need the braking resistors to enable for it to apply enough load for it not to switch off. If it switches off, then you've got 2000 watts of power going through your braking resistors and doing absolutely nothing. So it's very important to make sure that this inverter can take the load of the turbine. So that's 1800 watts capable, even though it's a 2000 watt turbine, 2000 watt inverter. This also blew up. This one blew all the input capacitors. The 2 input relays just melted. So I replaced the input relays, replaced all the capacitors on the input circuit, and then also there was 2 other transistors that burned out as well. So I replaced all those, working again. When this one burned out, what happened to this one was there was 2 output transistors, or MOSFETs, and both of the MOSFETs just blew. So I replaced those and back up and running again, no problem. And then once I got that one working, switched back to the 24 volt one, realised it wasn't powerful enough to hold this turbine, which is a BNC 1000 watt, and it's producing over 1000 watts. So this inverter cannot handle that wind turbine. So I started to use this one in the 24 volt board, which this can handle it. It's not going to drop out, but you've got to keep the voltage down. As you can see, the voltage is rising now to 34. Now you don't want it to go much above 40, because it is a 24 volt turbine. You can load it. So the idea is to get it loaded as much as possible on the low voltage. Yeah, this one it's now working okay. So like I say, you can convert them over to one to the other, solar or wind turbine, and you can change the voltage, etc. So that's it for now. When I get some more strong winds, which is sometime tomorrow, I may get up in the 1000 watt plus bracket. These are just winds that are coming, gusts that are coming through at present. You can see it just spins up so easy, and the brakes go on, which is the actual inverter loading the turbine. It slows it down again. So here we keep doing that on and off all the time, and it's reduced the. If you don't change the load on these things, the turbine makes a lot of noise. It spins really fast and starts to whistle, but by increasing the loading to stop it spinning just as fast, it's fine. It'll not make as much noise and it won't annoy your neighbours. So it's pretty good.